All right, guys, today we're going to talk about something called mass to mass conversions. So that's what you can title your notes. So we're going to get a pen out here and then for their title, and you're going to do these notes in your science lab book. So mass to mass conversions. In the upper left hand corner, just like we have done in the past, you're going to put the date. And in the upper right hand corner, you're going to put the page number. Okay, and so the best thing to describe this is you always use this with a balanced chemical equation. So we'll do a chemical equation here. Let's take hydrogen gas and we'll react it with oxygen gas, and we will that reaction will produce water, H2O. Okay? And you always have to use this with balanced chemical equations. If you notice here, this one is not balanced because we have two hydrogens that go into the reaction, two hydrogens that go out of the reaction. That is balanced. However, if you look at it with respect to oxygen, two oxygen atoms go into the reaction and only one oxygen is coming out of the reaction. So we do in fact have to balance this before we can really do anything with it. So what you'll notice is that we need more oxygen coming out on this side, so we need two oxygen coming out, and that will give us a balanced oxygen. So two oxygen go in, two oxygen come out. However, this two also corresponds and affects the hydrogen coming out. So by putting a two here, we now have four hydrogen coming out, and we need four hydrogen going in. So in order to get four hydrogen going in, we put a 2 right here, and that will give us 4 hydrogen total going in. Now, when you have a balanced chemical reaction, you can make several relationships. Okay, and so here's the relationships that we can make. We can make relationships between the same substances. Okay, so for example, we can make a relationship of hydrogen gas to how much it weighs. So, for example, 1 mole of H2 gas would weigh a certain amount of grams of H2. And we could find that on the periodic table. So if I minimize and bring up my periodic table, there are two hydrogen atoms that make up hydrogen gas. Each hydrogen atom weighs 1, so therefore 1 plus 1 gives you 2. So 2 grams of H2 would be equal to 1 mole of H2. Okay, we can do the same thing for each other substance in the reaction. So if you had 1 mole of O2, that also would have a certain mass. And from the periodic table, you see oxygen over here. And each oxygen, if you round this up, each oxygen will weigh 16 grams. So if I have two oxygens, like in this reaction here, 16 plus 16 would give you, oops, let me click off of that, would give you 32, I believe. Get off of that. Would give you 32 grams of oxygen. So 1 mole of oxygen would equal 32 grams of oxygen. And lastly, you could do this with water as well. So 1 mole of water would be equal to so many grams of water. And you could go on the periodic table and add up all those elements to figure out how much 1 mole of water would weigh. So we have two hydrogens. So um, H plus H, or 1 plus 1, would be 2. And then plus 16 would be a total of 18. So 1 mole of water would equal 18 grams of water. So these are relationships between the same substances. Oops. The same substances. Okay, so we go hydrogen to hydrogen and oxygen to oxygen and water to water. Okay, but from the balanced chemical equation, you could also make relationships between different substances, and that's where we use the mole to mole ratio. Okay, so let's over here, let's make another column. Get off that. Between different substances. So we'll highlight this differently. Okay, between different substances. And this is where we use the mole to mole ratio. So I can make the relationship between moles of H2 and moles of O2. There is a relationship there, and you get that from the balanced chemical equation. So it is 2 moles of H2 corresponds to 1 mole of O2. So 2 moles of H2 will react with 1 mole of O2. Well, I could make a relationship between moles of H2 and moles of product over here. So many moles of H2 will produce a number of moles of water, H2O. Okay? And you can tell that from the balanced chemical equation. So 2 moles of H2 will produce 2 moles of H2O. And then lastly, you can make a relationship between moles of O2 and moles of water. So if you look, 1 mole of oxygen, O2, will produce 2 moles of H2O. So 1 mole of O2 will produce 2 moles of H2O. So these are all the relationships that we can make from this balanced chemical equation. Now we're going to use these relationships to actually make some predictions. Here's the example problem that we're going to do. Okay. So what if you had 14.70 grams of hydrogen? Okay, so if you have 14.70 grams of hydrogen, how many grams of oxygen will also react? Okay, and so just like every other conversion, you first start with what you're given. So you are given 14.70 grams of hydrogen. So let's write that down. 14.70 grams of hydrogen. Okay, we're going to make our T table. And then this unit here is going to be moved down here. So let's just denote that. So this unit here is going to be moved down here, just like we always do. Okay, and I want to go to, if you look, I have only one conversion here that actually has grams of H2 in it. So let's circle that. Okay, grams of H2. And so its corresponding unit is moles of H2. So let's go to moles of H2. Okay, that's the other unit on the other side of this equality. So we're going to put the numerical values in front of the units now. So we're going to put 2 in front of the grams of H2, and we're going to put 1 in front of the moles of H2. Okay. Obviously down here we're going to put a happy face or just leave that blank. Just know that nothing goes down there. Okay. All right, we can cancel these units here. So this unit is going to cancel this unit, and the units we have are moles of H2 right now. Okay. I want to get to a different substance because my answer is going to be in terms of oxygen. Right now, my unit is in terms of H2, hydrogen gas. Okay, so we need to use a different equality. We need to use this equality over here. We need to use this guy because it has the unit I have and it has the substance that I'm wanting to go to. So we are going to add a T-box to, or a T-table to our current T-table. This unit is going to go down here. It always goes down here. The unit that we're going to, moles of O2, goes up above. Okay, and we're going to put the numerical values from the equality in here. So 2 moles of H2 will react with 1 mole of O2. So down here, 2 moles of H2 will react with 1 mole of O2. Okay. Of course, the units will cancel. Moles of H2 will cancel with moles of H2, and then we're left with moles of O2. Okay. Well, we want grams of O2. Okay. This is where we come over here. Look, we have moles of O2. That's the unit that we have right now. And there's an equality between moles of O2 and grams of O2. So now what we want to do is we want to use this equality. Okay, so we're going to add the T-table. Okay. We're going to take this unit, moles of O2, and that comes down. And then the other unit that we're going to finish off with is grams of O2, and we're going to put the numerical values for this equality over in our T-table. So 1 mole of O2 is equal to 32 grams of O2. Okay. Oops. Cancel your units. So moles of O2 will cancel. And the units that we have left are just grams of O2, which is exactly what we're looking for as our answer. Okay. All right, now let's pull out our calculator here and let's do this calculation. So this is going to be 14.70 times 32 divided by 2 divided by 2. So 14.70 times 32. Okay, and then we're going to divide the bottom one at a time. So we're going to hit divided by 2 and then enter, and then divided by 2 and then hit enter, and that should be our answer. Okay. If I look over here, I need to now consider significant figures. There are 4 significant figures in this value, and there should be 4 significant figures in this value. Well, we're only getting 4 here, so we're just going to write the whole thing down. So your answer should be 117.6 grams of O2, and that should be your answer.